Introduction. Every day people around the world burn huge amounts of gasoline as they drive their cars and trucks. As a matter of fact, in 2005, more than 870 million gallons of gasoline were burned. In the United States alone, people burned more than 380 million gallons, or 44% of the amount of gasoline burned in the world. Year after year, the amount of gasoline people consume just keeps increasing. But this gas-guzzling appetite can't last forever. Our supplies of gasoline is limited. Someday we will run out of oil that's used to make gasoline. By some estimates, the world only had 120 years of oil left. Some oil supply experts about 2050, oil production will begin dropping, and by 2025, oil will be scarce. Running out of gasoline is not the only problem of gas-guzzling appetites caused. The gasoline will burn to drive our cars and trucks release pollutants into the air. Most scientists believe these pollutants trap excess heat near Earth's surface. This heat is the major cause of global warming, which is slowly heating up Earth's atmosphere, changing weather patterns and melting Earth's ice sheets and glaciers. It does not paint a very bright picture for people driving gasoline-powered cars. So inventors, with an eye towards solving the present-day problem of global warming and the future problem running out of oil, are looking for new ways to power cars and trucks. They are looking for alternative fuels and inventing cars that can run on these fuels. This book is about possible fuels of the future and vehicles that can use these fuels. Solar-powered cars. All the energy we use comes from a big star in our sky, the sun. Even coal and oil, because they form things that were once when we burn coal, oil, and gasoline made from oil, we're actually releasing energy from the sun. Energy that we store in these fuels for long periods of time. And so it's important to know why it looks millions of years for coal and oil to form. For this reason, once these fuels are used up, supply is going to be replaced quickly. Scientists have found a way to change radiant energy from the sun directly into electricity. That's right, electricity can be made from sunlight. This electricity can then be used to light cities and power cars. Do you know? The sunlight falling on just 1 square meter, 10.8 square feet of land can produce enough electricity each day of like 10 100-watt light bulbs. All this is possible because of solar cells. You probably see your solar cells on calculators. They also be used to supply electricity to spacecraft and to devices found where no source of electricity existed. Solar cells do not get used up as batteries do. Instead, they keep on supplying electricity as long as there is light energy for cells to absorb. A group of solar cells placed together is a solar panel. Solar panels are placed on roofs of buildings. They can also be attached on satellites and space stations. A solar-powered car is covered with solar panels. All these panels produce enough electricity to run a special motor in a solar car, supply homes and supply a space station with all its energy. And all the energy comes without releasing pollutants into the air. So why aren't we powering all cores with solar cells, you may ask? The first reason is because of manufacturing solar cells. Scientists have not found a way to inexpensively manufacture the solar cells to convert its free energy to electricity offsets the savings. Well, energy output is another issue. Well, newer solar cells produce far more energy than the first models did. It still cannot equal the energy produced by burning gasoline engine. The top speed of a typical solar-powered car is about 60 meters per hour, 96.6 kilometers per hour. Even then, it takes hundreds of solar cells to generate enough electrical power to reach its speed. Then, of course, there's the issue of night driving and low sunlight days. Cars to operate around the clock, there has to be a way of storing the energy produced during daylight hours for use when there's no sunlight, or there has to be backup power supply. In all time, these problems may be solved. And with oil supplies diminishing, you can safely bet that an army of scientists is working on solving these problems. In fact, every year teams of students from colleges in the United States and Canada compete in a North American race of solar power cars. It is events like these that continue to push advances in solar cell technology. Hydrogen powered cars. Elements are simple substances. Things on Earth are made. There are just 92 natural elements, and they combine to make thousands of other substances, such as water, plastic, and sugar. Hydrogen is both the lightest and the most abundant of these 92 elements. As a pure element, it exists as gaseous state of matter. You cannot see it, and it has no odor. Hydrogen is one of two elements that make up water, and we all know how abundant water is, since it covers almost 75% of Earth's surface. It is also found in all living things, including plants and animals, as well as the remains of all living things. Hydrogen facts or combines well with other elements to make new substances. When combined with other elements, it releases energy. As the energy the hydrogen reactions release, the scientists so excited. Scientists imagine someday filling car gas tanks with hydrogen gas cans instead of liquid gasoline. But hydrogen is not found in pure form on Earth. So where will we get this hydrogen? Well, one of the most obvious places is from water. Water is made up of two elements, oxygen and hydrogen. All elements are made of tiny particles called atoms. Atoms of hydrogen and oxygen are held together by a chemical bond that makes a new substance, water. Breaking these bonds produce pure hydrogen and oxygen. The hydrogen can then be used as a fuel. There are several ways to break the bond between hydrogen and oxygen atoms in water. One way is to use a charge of electrical energy to break the bond. Another way is to use extreme heat. Earth substances like methane, a natural gas, are made of hydrogen along with oxygen and another element called carbon. Helium steam can break the bond between hydrogen atoms and atoms of carbon and oxygen. This also produces pure hydrogen. Once you have pure hydrogen, you can use it to power cars and trucks. Pure hydrogen is used in one of two ways. One way is to burn it in an engine in such a same way that cars burn gas. The other way is to use it to make electricity that can then power vehicles. Electric cars that use hydrogen have fuel cells that make electricity. These fuel cells are somewhat like batteries. Why? Do you know? Some tiny invisible organism called bacteria can produce pure hydrogen. Chemicals inside the organisms absorb energy from sun, which the organism then uses to split the bond between hydrogen and oxygen in water. In a fuel cell, hydrogen is combined with oxygen to form water. When the two elements join together, they release energy in the form of electricity. This energy can be used to power all kinds of vehicles. No matter how hydrogen is used, it is combined with oxygen to release its energy. And pure water is the only waste product. Since water is not a pollutant, it does not harm the environment. In fact, among the abundance of water on Earth, makes hydrogen a great alternative fuel. Although a lot more research is needed to make it work well. Battery-powered cars. Scientists are currently working on cars that are powered entirely by rechargeable chemical batteries. If you look under the hood of one of these cars, you will find an electric motor. Under the hood of gasoline-powered cars, you will find the hoses that carry water to cool an engine and exhausted pipes that carry away waste products. In contrast, there's a mass of wires under the hood of an electric car. In an electric car, there's no need to cool the engine and there are no exhausted gas produced that pollute the air. Instead of driving your car up to the gas pump to fill the tank with gasoline, you simply plug your battery-powered car into an outlet to recharge the car's batteries. And instead of a fuel bill, you pay an electric bill. Hybrid cars have an electric motor and a small gasoline engine. They both provide kinds of power to run the car. The electric motor runs on battery, but the motor has the ability to draw electricity from the batteries as well as to put electricity back into batteries. This means the batteries do not have to be plugged into electrical sources for recharging. The electric motor, when not powering the car, is putting energy back into the batteries. Ethanol power cars. Ethanol is an alternative fuel that's gaining popularity in many places around the world. What makes ethanol so popular is that it's a renewable resource. Fuels like coal when oil cannot be renewed. Once they're used up, they're gone forever. Ethanol can be made from plant and animal material. Most ethanol is made from grain crops like corn, barley, and sorghum. Ethanol is also made from potatoes and sugarcane. But it can also be made out of wood and other plants and animal materials. So, if we want to produce more ethanol, we just have to plant more crops like corn and sugarcane. In a matter of months, the crop is grown, can be harvested, and then used to make ethanol. To make ethanol from biomass means changing the plant matter into sugar. And sugar is then changed to alcohol in a process called fermentation. The diagram below shows a step of one way of making ethanol from corn. Pure ethanol can be burned in vehicles with special engines designed to burn it, or it can be mixed with gasoline and then burn in a regular engine. When ethanol is mixed with gasoline, it reduces the consumption of fossil fuels and reduces pollution. What's in the future? One thing you conclude by now is that supplies of oil to make gasoline won't last forever. We can look at ways to make the current oil supplies last longer by conserving gasoline. This can be done by driving cars with greater fuel efficiency, carpooling, or simply driving less. Whatever we do to conserve, we still have to plan for a day when there will be no oil for making gasoline. Scientists are hard at work seeking alternative means for powering our cars and trucks. Will the popular choice be ethanol, hydrogen, solar energy, or chemical batteries? The alternative that wins are likely will depend on economic factors. Two important economic factors will be the cost to produce the alternative power supply and the eventual cost of the alternative fuel to the driver. What do you think you'll be using to power your car when you're 70 years old? Bye!